Hello, everybody. What I would like to talk to you about today is a offering from Cadence on the HiFi DSP. What we have is generally a end-to-end software solution for both machine learning using TensorFlow Lite for microcontrollers and a middleware that we have been developing in the past few years that's recently been deployed to give you a end-to-end, not only machine learning solution, but also a system solution. When people talk about machine learning, the first thing comes in mind is almost, oh, computer vision. That is probably the biggest application for machine learning that takes a lot of compute powers. What I would like to talk to you about today is machine learning application in voice, anything with a microphone. With the popularity of voice assistants such as Alexa, Google Assistant, Siri, that's in your home, in your car, on your mobile devices, in your earbuds, these assistants have become very popular. The engine behind these assistants are multifold. A lot of them use machine learning. For example, the voice wake word, voice trigger, voice recognition, natural language speaking. What people don't know a lot is speech enhancement, noise reduction, that's gaining popularity by using machine learning. And also sound analysis, sound analytics, such as detecting your environment, your audio scene detection, detect like baby cry, gunshots type of application. One application that's is popular is the Pixel phone that gives you song ID when you listen to music. So the trend is that these applications initially all started going in the cloud. The trend is that depend on the privacy, latency, and availability of your network has driven more and more of the processing into the edge devices. I want to talk about a little bit about when people talk about availability of network. Example has always been used. For example, if you're driving a car, you may not have network. Recently, there's something that happened probably impact all of our lives is the current situation. We're all staying home. We're all trying to not to infect each other. One thing that's found in China was that the elevators is a source of infection. People touch the buttons in the elevator. So there has been a rapid development of the voice command to control the elevator. And the study had found that in most cases, these elevators do not have access to any network. So in a matter of a few days, teams of engineers in tech industry had developed solutions to the elevator that overcome one, there's network availability issues. Two, the environment is noisy. It's in an enclosed space, so the noise is different. When the elevator goes up and down, it's a different type of noise. In a matter of days, a system has been deployed in Beijing, China, that is capable of using voice control to control the elevator. And I'm proud to say that the system is using a HiFi 4 DSP. It's a voice AI processor that's powered by HiFi 4 DSP that uses one of our ecosystem partners solution that was able to deploy this solution. And many of these type of systems will be deployed all throughout China. So that's close to heart. So why HiFi DSP? It is a leading provider for audio, speech, and machine learning applications. We ship almost 1 to 2 billion cores per year. So the application has been used in the DSP, on the DSP, in multiple fields. For the most part, it's been in the voice trigger, voice command, and pre-processing, and speech enhancement. What we have found is, even though the DSP is capable of machine learning application, to actually develop the solution takes a lot of time. So we're motivated to provide a solution so that we enable innovation without taking months and even years of development effort. We have extensive product-ready software solutions from Cadence, and we have a very large software system that are innovating and providing solutions. And on top of that, we think that even though you may have individual solutions, but being able to put the system together, it's still a daunting task. So for some of the companies, the desire is that there should be a unified solution so that we spend the time to innovate rather than spend the time to trying to clean the pipe. So we have a solution that helps you to clean the pipe. Let's talk about conceptually what an end-to-end solution would look like. So we all know that for training, mostly you do the training in the cloud with almost unlimited compute power. You go through iterations, and you define your topology of your network, and you look at the data, you train, and in the end, you get a trained model. If you do nothing from what you get from the cloud, you get the parameters for your weights, and you get a Python code, and then you deploy that directly onto your device. Conceptually, this will work if you have unlimited compute power, if you don't care about power consumption. But for the most part, if you try to deploy such network, it would not work on the edge device. So there's many challenges if you try to deploy the trained neural network on your edge device. As many have mentioned, that you have power constraint, you have memory constraint, the generated code may not run on your embedded device. If you take all the work manually, you try to trim the network, you try to generate code, as an example, just to generate C code from a Python code alone, that could take you many, many weeks, even months, just after you have already know that you trimmed everything, just a matter of code. So there's the challenges for the edge devices is not a small effort. So some techniques of how to reduce the complexity, reduce the model size, so it's suitable for your edge device. So we go through the training the way we saw in the previous slides. After that, you get a trained model. From the trained model, you would want to prune your model, pruning meaning both from the size of the model to the computation complexity. So you go through iterations to make sure your training, your pruning and your compression does not compromise your trained network accuracy. After that, to put it on the edge device that has limited computational capability, you may want to, and also memory constraint, you may want to further trim your model by quantize your parameters. That alone is another iteration process. Once you get it quantized to, as someone mentioned, 16-bit, 8-bit, even maybe binary, in which case you would have to check and go through iterations to make sure that your quantized network would still give you satisfying accuracy. So after such trimming, you still have to go through a process of generating code that based on the Python. Most of the training framework are based on Python, so you still have to generate code, C code that your edge device can use. From that, depends on how good your compiler is. You can generate somewhat decent code. In most cases, you would have to further optimize that to be able to fully utilize whatever engine you're using on your edge device. In the end, you still have to integrate your solution with your system. So this manual process can take many, many months of work. Recently, I think this has been mentioned by Linley, that there is a movement from cloud to the edge, and there's the tiny ML that's, I would say, in the front line of this movement. The team at Google has developed what we call the TensorFlow Lite for microcontrollers, just abbreviate as TFLM in the rest of this presentation. It provides tools to seamlessly deploy your trained network, mostly at this point is TensorFlow trained network, into a C++ or C programmable edge devices. So for that, this was developed for tiny little microcontrollers, but the limitation of this microcontrollers is probably not suitable for most of these applications we have mentioned, that you have, not only you have the voice recognition, voice trigger, but also you have to clean up your signal, clean up the environment, noise. Sometimes it's probably a multi-mic processing. So this is actually a very, very natural fit for the Tensilica HiFi DSP. It gives you more processing power. It has many, many software solutions already available. So this is a natural fit. We see it as a bridge from trained network from the cloud into using the HiFi DSP. So what does it mean by seamlessly deploy? So the concept of the TFLM framework is generally up till the trained model. From there, it deploys, it gives you all the tools to, this is the flat buffer that's known in TensorFlow Lite. And from there, there is a conversion tool that converts your trained model into a much smaller model that your edge device can deploy directly. That it has smaller model and C++ code that's ready to deploy. When you are ready to deploy, so you would write your application as so, you call the TensorFlow interpreter runtime that's able to interpret this trimmed model. And from there, there is a set of defined operators that's been evolving quickly still. And then you deploy TensorFlow-like micromodel. And from there, that's where the HiFi DSP connects directly into here. We have mapped that code into the HiFi DSP. HiFi DSP can directly compile the TensorFlow like micromodel from the C code. From there, we provide two libraries. One is what we call the neural network library. The other library is what we call the DSP library. So it solves both the neural network based application as well as the feature extraction, such as FFT type of application. So it's a seamless integration with the system. So I want to talk a little bit about the optimized DSP optimized libraries. We provide two libraries. One is what we call the NNLib, which is neural network specific, like your CNNs, your DNNs, not just the kernels, but also layers with activation functions. We provide a thin layer on top of that to integrate directly with TensorFlow Lite for microcontroller. Another library we do provide is what we call the nature DSP library. That's your traditional DSP functions that's been used for many years. We've had this many years, and it's been used in probably billions of cores. These are all optimized for all of Tensilica HiFi DSPs. We have a family of audio DSPs that scales from tiniest device such as earbuds all the way up to bigger automotive or smart speaker type of application. The library supports all different precision of SIMD, and it supports the vector floating point. And it is framework agnostic, so it will work with any framework you would use. So we have done what we call a pipe cleaner using an example code from TensorFlow Macro Lite. Basically, it is a simple speech recognition application. So we take a signal, we recorded that, our own signal, and that's the yes is someone in my team speaking. So you go through spectrogram. This can be null frequency or just FFT. And then you feed that into your inference engine. And notice that the two, actually the spectrogram, how you do the spectrogram and your inference engine are tightly coupled if you look at the parameters carefully. So how you define your network and how you define your feature extraction are tightly coupled. So we were able to run this on the actual reference board from NXP that has been, it's sold publicly. So we just take the board and run the TensorFlow Macro Lite on the platform. Unfortunately, we're not able to demo it today. I don't have access to the board since we've been not in the office for many days, but this does work. We have a demo.
Yipeng, we need to wrap up now so we can go to the Q&A.
Yes. Here's an example of a system integration that we integrate many different components, including the keyword spotter that we just showed, and with the pre-processing, capture, render different components. To do that, we provide what we call a middleware for faster system integration. This is available. We have managed the memory, it can dynamically install, uninstall different components. these components come from Cadence or from our ecosystem partners. So we provide this framework to make integration much, much easier. So this is available in open source. So anyone who has a HiFi DSP can use this.
Okay, let's go to the Q&A now, Yipeng. So just question then on using HiFi for AI. You mentioned earlier a lot of the applications tend to be about vision processing. You wouldn't run a vision network on HiFi, would you? Or could you do both that as well as audio?
It's primarily audio. If one desires, you can probably run a small vision application on the HiFi DSP. It is not in terms of neural network. It's not audio specific. However, the interface, the framework so far we have is more focused on audio.
Sure, it makes sense that Cadence offers other cores that are more optimized for computer vision.
Yes, so it's mostly the software that's provided for the different platforms. And also, remember for the HiFi DSP, it's a more balanced DSP, I would say, that it has both the performance for your audio and voice pre-processing with high precision MAC and a low precision MAC for machine learning, for neural network, especially that we have the HiFi 5 we introduced last year. It's a very balanced processing. However, it's not a very heavy machine. The MAC capabilities is more suitable for audio.
Sure, sure. And how well does TensorFlow Lite support the kind of neural networks you want to use for say, keyword recognition? It's a different type of model. It's not necessarily a CNN. You'd maybe use an LSTM architecture.
So currently, the one we have deployed is more of a CNN-DNN model. However, our neural network library provides layers, including LSTM and GRU. We have very, very good performance on those. So we provide not just the MAC itself, but we provide the whole layers, and that makes the integration of much easier.
So how would that change the training process then?
It would not change the training process per se. So we look at what networks are popular for audio and voice application and solution. Then we make a conscious decision on what we actually go do and optimize both our DSPs and our software to work with the network.
Okay. One of the audience questions, somebody who may be familiar with TensorFlow Lite said that it has a problem with handling sparse matrices. Do you see that as an issue for HiFi to run with TensorFlow Lite?
So HiFi doesn't specifically change how TensorFlow runs. It just runs it very efficiently. So HiFi DSP, if it's a memory bandwidth issue, for example, sparse matrices, so it basically whatever comes out, we make the most out of it. And the HiFi DSP is capable of actually for the HiFi 5, for example, it is capable of compressing the when you do load, it's capable of compressing the coefficients. Mm-hmm. And all the HiFi DSPs you can add a DMA engine to make the bringing in the data more efficiently. So for the most part, the trained model are sequential are sequential and predictable way of bringing in the data. So using a DMA would be alleviate the problems.
You showed some options for using lower precision quantization. Is that something you're supporting down to binary neural networks?
So our DSPs support 4-bit, 8-bit. If you have a 1-bit, if you have a 1-bit model, we're capable of supporting it. Not that we invent the quantization. We are actually looking at quantization methodology themselves, and we are doing study of different type of quantization and how it applies to our DSPs. But for the most part, we let the inventors of the network to decide.
That's under their control when they're running the TensorFlow Lite training.
I'm sorry?
Is that under the user's control then, or does it automatically decide what the optimal quantization is?
That's under user's control. You can use different quantization resolution, and the DSP is capable of loading the different resolution into the computation unit.
Okay. There's a question on, could you give an example of power consumption for a keyword spotting application?
We have data. It's very, very low. So many of the devices out there actually do use HiFi as the voice trigger engine. So I can tell you, I don't have the data on top of my head, but I can say that on one of the earlier tablet that's using a HiFi as a voice trigger engine, if you don't actually turn on, so we had one in our office, and we would call the voice trigger on a daily basis, and the battery stayed up for over a month. So I would say the voice trigger power consumption itself for that device is probably negligible. Mm-hmm.
Mm-hmm. You gave an example during your talk about the NXP evaluation board. Somebody was asking about any chips on the market that are using HiFi. Could you say what that chip is? It's an NXP processor.
That's an NXP. It's an RT600 series. It uses a HiFi 4. This is public information. If you go to NXP website, they have a community that's supporting the platform. It has a 600 megahertz HiFi 4 that's capable of supporting multi-mic processing, that support XAF. So this is publicly available. You can buy the board from the marketplace.
And I think furthermore, I'll let the audience know, you can read all about that chip on in Microprocessor Report. We've covered that design from NXP.
Thanks, Mike.
Okay, that'll wrap up this session. Thank you, Yipeng, and we'll see you later on in the breakout rooms.